Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is episode 11, Precision Production Planning. Poor planning leads to missed deadlines, idle machines, and stressed teams. But what if your production schedule was built on real-time data instead of assumptions? In this episode, we explore how smart manufacturers use machine data, material availability, and AI-powered simulations to create accurate, resilient production plans. You'll hear how companies in packaging, heavy industry, and cosmetics improved order fulfillment and cut downtime, all by planning based on facts, not forecasts. Factory on Air is brought to you by DBR77, the digital twin platform that transforms raw factory data into optimized executable schedules. Let's jump in.
Welcome to The Deep Dive, the show that cuts through the noise and gets straight to the crucial insights you need. Now, if you're in manufacturing, you probably know the drill all too well. That constant battle against delays, the unexpected downtime that just pops up, that frantic scramble to meet deadlines that suddenly feel, well, impossible. It's a familiar story. You've probably felt it, that nagging sense that your meticulously crafted production schedule, the one you spent hours on, is maybe built on shifting sand, like it's ready to crumble with the slightest hiccup. It's this feeling of perpetual uncertainty.
Yeah, it's a scenario played out in factories, really, globally, unfortunately. That feeling of always being reactive, rather than proactively in control.
That's it, exactly. And that's precisely why today we're diving deep into precise production planning. Our mission here is to really uncover how tapping into real-time operational data, embracing the, frankly, incredible power of advanced simulation, and leveraging these cutting-edge technologies can actually transform that chaotic, unpredictable production into a well-oiled, predictable system.
And it's achievable now more than ever.
Right. And this isn't just about theory or abstract ideas. We're talking practical, implementable strategies, things you can use to create schedules that are not only more realistic and, well, achievable, but also incredibly resilient when things inevitably go wrong.
Because they always do, eventually.
Exactly. We're drawing our insights primarily from a focus analysis on precise production planning itself, and we'll also be complementing that with some detailed information about a pretty comprehensive digital transformation platform known as DBR77. It really brings many of these powerful concepts to life for industrial operations.
What's fascinating here, I think, is that while the challenges are pretty universal across manufacturing, the sophisticated solutions to actually address them are now genuinely within reach. They're more accessible than they've ever been before.
Okay, so let's unpack this properly. We need to start by setting the stark reality. What really happens when production planning isn't precise? What are the profound ripple effects that, spread throughout an entire industrial operation, touching every single aspect of the business, often far beyond just the factory floor?
Yeah, the consequences are truly far-reaching, and they invariably impact the bottom line and, crucially, the long-term viability, the reputation of a company. One of the most immediate and frankly damaging effects is a direct hit on customer trust and reliable order fulfillment.
Ah, the customer side, right.
Exactly. When you experience delays in order fulfillment realizacji zamówień, it directly leads to a loss of customer trust, utrata zaufania klientów. This isn't just about a product being a day or two late. It's about fundamentally damaging the relationship with your clients. Imagine a customer needing a critical component for their own production line, right? And your promised delivery day slips. That can cascade into their own delays, penalties, a severe hit to their operation.
Right. It's not just your problem anymore.
Exactly. That kind of unreliability, it just tarnishes your reputation. And in a fiercely competitive market, well, it very often means losing future business to competitors who consistently show they can deliver predictably and on time. Reliability in delivery isn't just a nice-to-have anymore. It's a major competitive differentiator.
So it's not just a minor logistical snag. It escalates really quickly into a strategic blow that can erode your market position.
Precisely. And beyond customer relations, imprecise planning creates these pervasive operational inefficiencies that just drain resources. We see this manifest most commonly in frequent machine downtime versus doge machine.
The silent killer.
You could say that. These periods of idle machinery are often a direct result of a lack of materials. BRAC, material meaning components just aren't where they need to be when they need to be there. Or Conversely, it could be a line overload, preceunium linii, where one stage of production just overwhelms the capacity of the next.
Right.
Picture a high-value, expensive piece of machinery, maybe costing millions, just sitting completely idle because a critical component hasn't arrived on time, or because the previous workstation hasn't cleared its backlog. It's not just an idle machine, it represents an enormous loss of production capacity, wasted capital investment, and missed opportunities for revenue. It's a continuous, sort of insidious drain on profitability that can almost always be traced back to a flawed or inaccurate production schedule.
Hey, it's not just the machines that suffer, is it? There's a profound human cost, too, leading to a workforce that's, well, less efficient and probably less happy.
Absolutely. The human capital strain is immense and often, frankly, overlooked. Imprecise planning inevitably leads to excessive overtime nadgodzini, forcing employees to work longer hours, often under intense pressure, just to compensate for earlier planning failures.
That's unsustainable.
Totally. And it also creates an imbalanced team workload. Nisronowano, prakazespusho. Some teams might be completely swamped, struggling to keep up, while others are left waiting for materials or for machines to become available. That leads to frustration and underutilization. This isn't sustainable for any organization. It leads directly to employee burnout, significantly decreases morale across the factory floor, and dramatically increases labor costs, overtime premiums, potential turnover, all of it. A stressed, overworked workforce is also inherently more prone to errors, less likely to be innovative, and less engaged, which further impacts overall productivity and the quality of output. It's really a vicious cycle that depletes your most valuable asset, your people.
Which brings us neatly to resource misallocation. It sounds like having all the best, most expensive ingredients for a gourmet meal, but absolutely no recipe or coordination. So you just end up wasting most of them.
That's actually a perfect analogy.
Yeah.
We frequently observe the suboptimal utilization of available resources. Nieoptimalny, wykorzystanie, dostępność zasobów. This includes not only machines and people, but also the most finite resource we all have, time.
Right.
Every single minute, a machine is underutilized, or an employee is just waiting for the next task because the production flow is disrupted or unclear. That represents a direct and tangible hit to profitability. You've invested heavily in these assets. The machinery, the skilled labor, and imprecise planning directly prevents you from maximizing their output and their return on investment. It's a hidden cost that doesn't always show up clearly as a line item, but it adds up incredibly quickly and significantly affects your competitive edge.
And then there's the inevitable frantic firefighting. We mentioned the rush orders, the emergency shipments, the constant phone calls. It just sounds exhausting for everyone involved.
It absolutely is, and it's incredibly expensive too. These are the correction and logistics overheads. The koszty wynikające z konieczności korektowania i dodatkowej logistyki, costs arising from necessary schedule corrections and additional logistics, are often overlooked in initial planning, but they are substantial.
Yeah, I bet.
This covers everything from emergency shipments of parts that, frankly, should have been ordered weeks ago, to rush orders for missing components, and the constant administrative burden of adjusting plans, communicating endless changes to various departments, rescheduling operations. It's constant churning. All of these emergency measures eat directly into profit margins and, perhaps even more damagingly, divert valuable managerial and supervisory time away from strategic initiatives and continuous improvement efforts. It forces them into a reactive crisis management mode instead of proactive leadership.
So the stakes are incredibly high then. It's really clear that sticking with outdated, maybe manual or just imprecise planning methods is an incredibly expensive choice. It costs businesses in terms of lost customer trust, crippling operational efficiency, plummeting employee morale, and very direct financial terms. It's not just a departmental problem, is it? It's a systemic issue impacting the entire enterprise.
It truly is. The cumulative effect of all these pervasive issues can significantly erode a company's competitiveness and its long-term sustainability in the market. It's fundamental.
Okay, so given these pervasive and, frankly, costly challenges, how do we actually begin to build those more realistic, more robust schedules? Schedules that can not only function efficiently day to day, but also withstand the inevitable disruptions and variability of the real world. The answer, perhaps surprisingly to some, starts with something fundamental, something often underutilized: data. It's the absolute cornerstone, isn't it?
Data truly is the indispensable foundation. It provides the granular, the empirical insights you need to move beyond assumptions or gut feelings or just historical guesses and into truly informed real-time decision-making. First, just consider the power of real-time machine insights.
Okay.
Information streamed directly from the machines themselves, data points like precise cycle times, chassis cycle, for each operation, the exact machine availability, dostupność, at any given moment, and the duration and cause of any downtime, postoj. This allows for a much more accurate estimation of how much can realistically be produced in a given time. A realnie more wyprodukować w danym czasie.
Right.
This literally transforms planning from what used to be, often optimistic historical guesswork or rough projections into an empirical science. It's grounded in the actual current capabilities and performance of your equipment. You gain the ability to know precisely what each machine is doing, when it's available, and its true throughput capacity, all in real time.
So no more just guesstimating how long a production run will take based on last year's numbers or even last month's. It's live, active, precise information flowing constantly.
Exactly. Second, building on that, we need comprehensive inventory and material visibility. Having up-to-the-minute data about stock levels and material availability, zapisowy dostępności materiału, ensures that your production planning aligns directly with your aktualnymi możliwościami, your current capabilities and existing resources, rather than just relying on optimistic sales forecasts or, worse, outdated inventory counts from last week.
Which prevents that nightmare scenario of starting a job and then grinding to a halt.
Precisely. It avoids that incredibly frustrating and costly situation of starting a production run only to have to stop midway because a critical component is missing or unexpectedly delayed. By knowing exactly what materials are on hand, what's inbound, and when it's expected, you can plan production runs with absolute confidence, optimizing material flow, minimizing bottlenecks, and preventing those costly stoppages due to shortages.
And it's not just about the machines and the materials, is it? It's also profoundly about the people involved. Human resource optimization based on data sounds absolutely crucial for a balanced and productive operation.
Indeed. Analyzing the human resource load, obciążenie zasobów ludzkich, provides invaluable insights that help you avoid overloads, on specific teams or individuals. And just as importantly, it helps prevent errors resulting from personnel shortages, on critical tasks.
Makes sense.
By understanding team capacities, individual skill sets, and current assignments in real time, you can ensure the right people are in the right place at the right time. This prevents employee burnout. It optimizes individual and team productivity by preventing idle time or excessive stress, and it ensures that critical tasks are performed by adequately staffed teams, significantly reducing the likelihood of human error or costly delays just because someone wasn't available. Data truly transforms this from a complex, often manual scheduling challenge into a strategic deployment of your most valuable asset, your workforce.
Here's where it gets really interesting, I think. It's not just about collecting all this data, as vital as that obviously is, but it's about how that data then empowers foresight and robust decision-making. And that's precisely where simulation comes into play, right? Creating this dynamic virtual testing ground for your entire operation before you commit any real-world resources.
Simulation is indeed the next critical step after you've got that comprehensive data collection sorted. It allows businesses to test and validate various proposed plans and operational changes in a completely risk-free virtual environment before committing valuable real-world resources, time, or capital. Simulations enable companies to test countless schedule variants, harmonogramme, before they are ever implemented on the factory floor.
That sounds incredibly powerful.
It's a profound game changer because it allows you to identify and prevent potentially costly real-world errors, widespread disruptions, and expensive rework. Instead of discovering a plan has inherent flaws only after you've already invested time, money, and effort, you can identify, analyze, and correct those flaws virtually, safely, and importantly, cost-effectively.
So it's literally like having a crystal ball for your production line, letting you see the future outcomes of a multitude of different decisions without any of the real-world consequences if you get it wrong. What kind of complex scenarios can you actually model with this technology?
Oh, the possibilities are incredibly extensive and deep. For instance, you can model the effecti dodanias mismian lub, now as the simid imprecision of adding shifts, or introducing new machines, or even reconfiguring existing production lines. You can understand the precise impact on overall throughput, efficiency, lead times, all before making any significant capital investments or disrupting your current operations. You can also analyze the exact wupju aweri lib opuji material shortage now realizać plano the impact of potential failures, like a key machine breakdown or unexpected material delays on the execution of your current plans. This allows you to build greater resilience and contingency into your schedules by anticipating these potential disruptions.
The what-ifs.
Exactly. Crucially, you can run countless what-if scenarios that goes easily. What if order volumes suddenly increase by 30% next quarter? What if a key supplier experiences unforeseen delays that push back material delivery by a week? What if a major client demands a shortened deadline for a rush order? This unparalleled capability it facilitates choosing the absolute best plan from a range of options and, just as importantly, allows you to prepare proactively for those unforeseen situations. It fundamentally shifts you from reacting to problems as they emerge to proactively planning for them, mitigating their impact before they even occur.
This isn't just theoretical then. It's about creating a dynamic, virtual sandbox where you can experiment with and refine your entire operation. And to deepen this, you mentioned earlier we introduced the truly transformative concept of a digital twin Cyphery Bluniac, which takes this simulation capability to an entirely new level of precision and real-time responsiveness.
That's right. A digital twin is much more than just a static simulation model. It's a dynamic, virtually imaginative model, a virtual and mathematical model of your real manufacturing plant or logistics center. It provides advanced 3D simulation capabilities, but critically, it's constantly integrated with real-time IoT data flowing directly from the physical world, from your machines, your sensors. This creates a living, breathing digital replica that mirrors your actual operations with remarkable accuracy and real-time fidelity.
So it's not just a static blueprint, it's dynamically updated with live data from every sensor and machine on the factory floor, almost like a real-time pulse of your entire operation displayed digitally.
Precisely. This constant real-time data synchronization allows for continuous monitoring, analyzing, or as optimal process does his monitoring, analysis, and optimization of processes in real time. Imagine being able to see your entire factory flow, identify developing bottlenecks before they actually cause a problem, check the precise status of every single machine, track material movements, all reflected digitally, live, right there on your screen.
That visibility alone must be incredible.
It is. And crucially, users can test different scenarios, identify potential bottlenecks before they become actual problems, and accurately predict the outcomes of proposed changes, frisco to Bizakukania Bisuk Aparachi, all without disturbing current operations in the physical plant. This means you can run hundreds of experiments, optimize processes, iron out kinks virtually, ensuring that any changes you implement in the physical world have already been proven effective and optimal in the digital one. This functionality significantly Przyczynia do redukcji kosztów operacyjnych, zwiększenia wydajności oraz skrócenia kosztów na zmieniające się warunki produkcyjne. It contributes to reducing operating costs, increasing efficiency, and dramatically shortening your reaction time to changing production conditions or unexpected events.
So what does this all mean for you, the listener, the manufacturing professional, in terms of tangible, measurable, and impactful results? Are there actually companies out there that have truly mastered this kind of precise planning and seen quantifiable benefits?
Absolutely. And the success stories are not only compelling, but also clearly illustrate that these aren't just, theoretical gains. They are real-world transformations impacting the bottom line. For example, there's a case of a producer in Opakoa, a packaging producer. After implementing a data and simulation-based planning system, the skrócić gaz realizacji zamowy in over 20%. They reduced their order fulfillment time by a massive 20%.
20%. Packaging, that's huge.
It's enormous. In a highly competitive market like packaging, where lead times are absolutely paramount, reducing your delivery time by a fifth can literally be the difference between winning and losing major contracts. It means faster cash flow, greater customer satisfaction, and the ability to take on more orders without actually increasing physical capacity. They effectively shifted from being reactive to market demands to proactively dictating their delivery capabilities.
Yeah, a 20% reduction in lead time isn't just an improvement, that's a genuine game changer. It opens up entirely new strategic possibilities for them.
It really does. Another powerful example comes from a Fabrica Przemysłu Chirikigo, a heavy industry factory. They achieved a 15% reduction in costly downtime. How? Through precision planowanie czasu cycling na podstawie danych IoT, precise cycle time planning based on IoT data flowing from their machines.
15% downtime reduction in heavy industry.
Wow. Think about the scale here. Downtime in heavy industry, where machines are enormous, complex, and incredibly expensive to run and maintain, can cost hundreds of thousands, if not millions, of dollars per hour. A 15% reduction in these unplanned stoppages means dramatically higher output, fewer delayed projects, and massive cost savings. By leveraging that real-time data from their equipment, they could predict maintenance needs, optimize throughput, and ensure the right resources were available at the right time, keeping those high-value machines running consistently.
Yeah, downtime in heavy industry can be astronomically expensive, so 15% is a monumental win. That impacts profitability and operational stability in a big way.
Indeed. And one final example, consider a Zakio Produci Cosmetico, a cosmetics plant. They managed to unique-notch 80% Producico, Naguchujujuko, avoid 80% of their sudden downtimes thanks to significantly better planning of component availability.
80%? Huh.
Simply by having much better visibility and planning around their components. Before this, they might have faced frequent stoppages just because a specific chemical or a particular packaging material wasn't available at the exact moment it was needed on the line. This really shows the profound power of having clear, real-time visibility into your materials and inventory. By ensuring that every necessary part or ingredient is precisely where it needs to be, when it needs to be there, they proactively prevented nearly all of their costly stoppages. This led to much smoother production runs, higher product quality consistency, and far less waste.
These aren't just incremental improvements, are they? These are significant, transformative shifts that profoundly impact the bottom line, enhance market competitiveness, and fundamentally change how a company operates day to day. These are truly impressive results that really underscore the undeniable power of data-driven, precise planning.
Yeah, the common thread across all these examples is that profound shift from a reactive, firefighting approach to a proactive, optimized, and predictive mode of operation.
It changes everything. Okay, now, let's look at a platform that actually integrates these advanced concepts, the real-time data, the digital twins, the AI, into a single cohesive system, something that makes them accessible and actionable for manufacturing professionals. You mentioned it earlier, DBR77. How does DBR77 specifically address the needs for precise production planning and bring all these elements together in a practical solution?
Right. DBR77 is designed precisely for this. It's a comprehensive digital transformation platform, and its core mission aligns perfectly with the principles of precise planning we've been discussing. First off, it tackles that fundamental data challenge by seamlessly connecting Dane Z Mazin, Magazino, E-System, products match, WNCS, system data from machines, warehouses, and existing production systems in real time.
Okay, getting it all in one place.
Exactly. And this isn't just about collecting data. It's about integrating disparate sources to create a unified single source of truth for all operational data. This eliminates discrepancies, ensures consistency, and provides everyone in the organization, from the shop floor to the top floor, with the most current, accurate information. That alone is a massive challenge for many manufacturers today.
So it's not merely collecting data in separate silos, but intelligently integrating it across the entire operational ecosystem, allowing for a truly holistic view.
That's the idea. And building on that integrated data foundation, its Cypherui Bliuniaxakadu, its digital twin of the plant, enables that powerful simulacja harmonogamo gordowisku simulation of schedules in a dynamic virtual environment. This is where all those what-if scenarios we talked about earlier really come to life. You can model proposed changes to your production lines. You can simulate the impact of new, large production orders, or even test the effects of potential disruptions, like a supplier delay, all within this virtual replica to see their exact impact before making any real-world commitments. This significantly de-risks those big planning decisions and allows for extensive optimization without interrupting live production.
And it doesn't stop just at simulation. This platform also leverages the power of artificial intelligence, right? How does AI fit into optimizing these incredibly complex schedules that have so many different variables flying around?
Yeah, that's where the deep intelligence truly comes in. DBR77's sophisticated algorithm AI algorithms analyze critical operational factors across the board.
Yeah.
They look at the precise machine load across your entire facility to ensure equipment is utilized efficiently without being overstressed or, just as bad, underutilized. They analyze the optimal Kolenia-Sheparaki sequence of operations, identifying the most efficient flow to minimize bottlenecks and maximize throughput. And crucially, they factor in the real-time dostępność materiału I przekandyko, availability of materials and employees, ensuring that all necessary resources are aligned precisely with the production plan.
So it ties everything together.
Exactly. Dete postawi generowane, zoptymalizowane harmonogramy produkcji, gotowi do używania. Based on this complex, real-time, multivariate analysis, Optimized production schedules are intelligently generated, ready for immediate implementation. It's not just reporting data back to you, it's actively processing it, learning from it, and optimizing it to give you the best possible plan based on current reality.
It truly sounds like a comprehensive, intelligent brain for the factory floor, making sense of an incredibly complex web of variables and then spitting out an actionable, optimized plan. It seems like it takes a lot of the guesswork and, frankly, a lot of the stress out of production management.
It fundamentally shifts planning from what was often considered, an art or a craft, heavily reliant on intuition and experience, sometimes luck, to a rigorous data-driven science.
Let's break down the specific technologies within the DBR77 ecosystem even further. The ones that empower such precise planning. This is where we can really see the depth and sophistication of this kind of holistic solution and, importantly, how it handles some of those challenges you highlighted earlier about implementation.
Indeed, it's a carefully designed suite of integrated tools working in synergy. So, first, let's elaborate a bit more on the DBR77 digital twin itself. This isn't just like a basic 3D model you might see elsewhere. It creates a virtual S01E11, a virtual plant mapping, which is a dynamic virtual replica of an entire production facility.
Okay.
This 3D model is powered by continuous IoT data, accurately reflecting every production line, every individual machine, every material flow within the facility, all in real time. It's an incredibly precise, living digital mirror of your physical operations, updated literally moment by moment.
So it's constantly updated with exactly what's happening on the floor right now. That level of detail must be absolutely essential for truly effective simulation and decision-making, right?
Absolutely. This real-time fidelity enables its core function. Simulacja scenariosy, I testowanie rozwiązuję scenario simulation and solution testing, using advanced algorithms and, importantly, stochastic scenario analysis, which basically means it can account for random variables and uncertainties, like unexpected breakdowns. The digital twin allows you to simulate a vast array of operational variants.
Okay, handling randomness.
Exactly. Think of it. You can test changes in production layout to optimize physical flow. You can try out new line settings to boost efficiency, or even simulate the exact impact of unexpected events like a key machine breakdown or a sudden surge in demand. This capability is critical for identifying bottlenecks before they occur in the real world, accurately forecasting potential downtimes, and developing optimal implementation strategies for any changes you might be considering. It effectively eliminates that costly and disruptive trial and error process that often happens on the live production floor.
And it goes even further with visualization, doesn't it? Using technologies like virtual reality and augmented reality to make those simulations even more immersive and, I guess, understandable.
Yes, exactly. The realisticzny wizualizacji wykorzystaniiem VRR, realistic visualizations with VRR, allow managers and engineers to actually see and interact with simulated solutions in a highly realistic virtual environment. Imagine putting on a VR headset and literally walking through a proposed new factory layout before any walls are moved, or seeing augmented reality information overlaid on your physical machines in real time to understand their current performance or upcoming maintenance needs.
Wow, that's pretty futuristic.
It is, but it's practical. This immersive experience helps minimize errors before actual implementation because you can literally walk through the changes, evaluate material flows visually, spot potential ergonomic issues for workers, and identify problems that might be completely missed in traditional 2D diagrams or spreadsheets. It provides a level of understanding, collaboration, and confidence in decisions that's truly unprecedented.
That's an incredibly powerful combination. But as you said, a digital twin, no matter how advanced, is only as good as the data feeding it. So let's talk about the foundation. DBR77 IoT Itzawan Rozwiązania do Zbierania Danych, the Advanced Data Collection Solutions.
Right, the DBR77 IoT system is indeed foundational, acting almost like the nervous system for the entire platform. It uses its own dedicated precizioni sujniki infrastructure, precise sensors and infrastructure, which are installed directly on machines and across production facilities. These aren't just basic counters. They are intelligent sensors monitoring a vast array of critical parameters: temperature, pressure, machine uptime, energy consumption, exact cycle times, providing that precise, up-to-the-minute data essential for quick and accurate decisions. This is real-time, granular data, not generalized averages from outdated systems.
And all that data from all those different sensors and machines needs to flow seamlessly and reliably to the central platform to be truly useful, right?
Exactly. Integracja I konieczność integration and connectivity are key design principles. The system is meticulously designed for seamless integration with diverse devices and existing production systems that a factory might already have, like older legacy machines or different software vendors. This ensures a constant, uninterrupted, real-time data flow to the central DBR77 platform for immediate analysis and process correction. The benefits are clear. Significantly increased data accuracy, dramatically reduced analysis time, meaning decisions can potentially be made in minutes rather than hours or days, and often lowered data acquisition costs compared to manual methods. This leads directly to better operational management and faster, more accurate decisions, which are absolutely critical for precise planning and maintaining agility in a fast-moving market.
Okay, but processing all that torrent of data and turning it into actionable intelligence, that's where DBR77 AI, the Sztuczna Inteligencja Automatyzacja, artificial intelligence and automation, steps in. This sounds like what truly brings the factory data to life with smart insights.
Yeah, the DBR77 AI system is essentially the brain of the entire operation. Its AI for decision-operacy, operational decisions, intelligently analyzes the enormous amounts of data collected by the IoT sensors and generated by the simulations in the digital twin. It doesn't just present data dashboards, it actively identifies inefficiencies, it predicts potential failures often long before they occur, and it suggests optimal actions to take. There's even an embedded AI assistant that functions, essentially, like a virtual lean consultant, providing real-time, data-driven recommendations, helping managers and operators make smarter choices on the fly, and it's constantly learning and adapting.
So it's almost like having an expert consultant permanently analyzing your operations 24/7, providing immediate feedback and guidance based purely on the facts.
Pretty much. And it continually learns and improves. Through Uksini Mazino, modelowani scenario, machine learning and scenario modeling, its algorithms continuously evolve based on historical operational data from your specific plant. This learning enables the generation of synthetic data sets for training predictive models, allowing for even more precise forecasting of future events like demand spikes or maintenance needs, and enabling continuous process optimization. It truly gets smarter over time as it processes more of your factory's unique operational data, becoming increasingly tailored to your specific needs and challenges.
And this continuous learning then leads to a significant degree of automation in decision-making. That sounds like a massive efficiency booster for management.
Yes, to a significant and growing degree. The automatyzacja procesu decyzyjnych, automation of decision-making processes, is a key output. Based on advanced language models and statistical analyses, the system automatically generates comprehensive reports and, more importantly, actionable recommendations. This empowers managers to make quick, confident decisions based on solid evidence and dynamically adapt operational strategies to rapidly changing market conditions or unexpected internal events. It streamlines the entire analytical and decision-making process, providing clear, concise, and actionable insights rather than simply overwhelming users with raw data dumps.
Finally, there's the DBR77 marketplace, which you mentioned acts as a supporting element. How does this B2B platform for automatyzacja automation contribute to precise planning, even if indirectly? It seems like it plays more of a strategic enabling role.
That's exactly right. While not directly a planning tool itself, the DBR77 marketplace plays a vital and strategic supporting role that greatly amplifies the benefits you get from precise planning. It connects manufacturers, technology providers, over 800 of them, and integrators, around 600, in a single robust ecosystem. Its AI intelligently matches offers to specific client needs identified through planning and simulation.
Okay, so give me an example.
Okay, say your digital twin simulation identifies a persistent bottleneck that can be best solved by implementing a specific type of robotic arm or a new automated guided vehicle system. The marketplace significantly shortens the time needed for adopting that technology. The typical process for sourcing and implementing automation, from initial planning to full implementation, can traditionally take maybe 25 months or even longer. The DBR77 marketplace is designed to potentially shorten this implementation time by half and can help save up to 30% on costs at the purchase and implementation stage.
Wow, cutting implementation time in half is huge.
It is. This accelerated ability to acquire and implement the right solutions means you can act on your optimized plans much faster, bringing those real-world improvements and the resulting ROI much more quickly. It closes the loop between planning and execution much more effectively.
The synergy of all these technologies, the real-time IoT data feeding an intelligent digital twin, analyzed by AI, supported by a marketplace for rapid implementation, creates an incredibly powerful toolset for mastering production. It's clearly not just a collection of disparate features, it's a holistic approach that truly leverages the power of digital transformation for operational excellence, integrating every key aspect.
It creates an integrated, intelligent, and highly responsive ecosystem for the entire factory floor, transforming it from a series of disconnected processes into a dynamic, adaptive entity capable of much higher performance.
Okay, so after all this effort and technological investment, after embracing real-time data, simulation, platforms like DBR77, what are the concrete, measurable payoffs for businesses that really embrace precise planning? What do they actually gain on the ground, day in, day out?
The advantages are incredibly compelling, and they directly impact competitiveness, customer satisfaction, and, of course, the bottom line. First and foremost, as we discussed with the examples, there's a dramatic increase in timeliness. Vichasa terminowursh, rizachi zamovi, greater timeliness in order fulfillment. This means consistently meeting your deadlines, which, as we said, builds immense customer trust, fosters loyalty, and significantly strengthens your market position. You become known as the reliable partner, which is invaluable in almost any industry.
And presumably less frantic firefighting for management and supervisors, which is always a win for both morale and overall efficiency.
Absolutely. You'll see a substantial znanity look Lisby correct harmonogrammo reduction in the number of schedule corrections. Less rework. This frees up valuable managerial and operational time that would otherwise be spent firefighting, constantly adjusting plans on the fly, and dealing with unexpected disruptions. Instead, that precious time and energy can be reinvested in core production activities, continuous improvement initiatives, or even exploring new market opportunities. It shifts the focus from reactive chaos to proactive improvement.
Which naturally leads to much better resource utilization across the board, getting more from what you already have.
Precisely. There's a far more effectiveness, wickersysteni, ludzi, a vast more efficient use of both people and machines. By precisely matching tasks to available resources and optimizing workflows based on that real-time data, you maximize throughput with your existing assets. This means less idle time for expensive machinery, fewer instances of employees waiting around for work or materials, and a generally more productive, less stressed workforce. All of this leads to higher overall output without necessarily requiring significant new capital expenditure. You simply get more out of what you already have invested in.
And all of that increased efficiency and optimization directly translates into clear, quantifiable cost savings, doesn't it?
Indeed. You'll see a significant reduction nadgajin decosto awaring jajjajo reduction in overtime and emergency action costs. Those unplanned overtime shifts, the costly rush shipping fees to get components there yesterday, the last-minute component purchases at premium prices, all these expensive emergency measures are significantly reduced, or in many cases, entirely eliminated. This has a direct and highly positive impact on your profitability and your cash flow. Less money spent on fixing problems means more money kept on the bottom line.
And finally, there's that intangible but incredibly valuable benefit of enhanced trust both externally with your customers and internally within the organization itself.
Yes, absolutely. There's weekses, sofani, klientojiki, stabilnoshi, stabilowarnoshi, greater customer trust, due to stability and predictability. When your customers know they can consistently rely on your delivery promises, it builds deep loyalty and encourages repeat business and positive referrals. And importantly, this newfound stability also translates internally. It creates a calmer, more predictable, and ultimately more productive work environment for your employees, boosting morale and reducing stress. Everyone, from the CEO to the machine operator, benefits from a more reliable, predictable system.
These aren't just nice-to-haves or minor advantages, are they? These are absolutely essential for remaining competitive and thriving in today's fast-paced, often unpredictable industrial landscape. The benefits truly touch every single aspect of the business, from the top floor strategy right down to the factory floor execution.
It's about building a fundamentally robust, agile, and truly customer-centric industrial operation, one that can navigate complexity with confidence and grow strategically, rather than just struggling to keep up.
Okay, this all sounds incredibly powerful and truly transformative, but we know that implementing such sophisticated planning systems isn't always just a walk in the park. What are some of the common challenges or hurdles that companies typically face when they try to integrate these advanced solutions into their existing operations?
You're absolutely right. Implementation can definitely present significant hurdles. One of the primary obstacles that many companies grapple with is data inconsistency, Organizations often have Rune Erodu Denach, different data sources, maybe an ERP system here, an MES there, various IoT devices spitting out data, and their nispoinch inconsistency can be a major headache. Data might reside in different formats, be updated at different intervals, or simply not align across these systems, making it incredibly difficult to get that single, unified, accurate picture of operations we talked about.
Yeah, it's like trying to build a complex structure with bricks from different manufacturers that don't quite fit together properly. It leads to cracks and instability in your foundation.
That's a perfect analogy. And this often leads directly to a BRAC standardization damage, a lack of standardization. Data from machines might be collected in one format while manual records are kept entirely differently, or perhaps different machines from different vendors provide data in their own proprietary formats. This non-standardized data makes accurate, automated analysis extremely challenging, undermining the very foundation of precise planning and making it difficult for advanced systems like AI to make reliable sense of the information.
And then, as with any major change, there's the crucial human element. Change is never easy, is it? Especially when it comes to long-established ways of working on the shop floor or in the planning office.
Exactly. A poor organizational resistance is a significant human factor. Employees and management who have maybe grown accustomed to traditional methods of planning and operations over many years may naturally resist adopting new technologies. This resistance can stem from a fear of job changes, a perceived steep learning curve for the new tools, or simply the comfort of the familiar way of doing things. This inherent resistance can significantly slow down or even completely derail implementation efforts, regardless of how good the technology itself actually is.
Yeah, the "we've always done it this way" mentality can be a powerful blocker. And even with the best intentions from everyone, new tools always require proper training, which I suspect can often be underestimated in the planning phase.
Precisely. The Patebo Pascalenia Sespusho. The need for comprehensive team training in using new tools is often severely underestimated. Without proper ongoing training and support, even the most advanced and potentially intuitive systems will likely be underutilized, perhaps misused, or simply neglected altogether. This leads to frustration among employees and a perception that the technology isn't delivering its promised value, which ultimately hinders adoption and prevents the company from realizing the full ROI.
It's really clear the successful implementation isn't just about buying the right technology, but about proactively overcoming these systemic and human challenges within the organization. What's truly fascinating here, and something you touched on, is how a platform like DBR77 specifically seems to address many of these common pain points head-on, showing a practical, almost human-centric approach to the market's needs and making that path to digital transformation hopefully much smoother.
Indeed. DBR77 has systematically developed intelligent solutions for these very challenges, demonstrating, I think, a deep understanding of the real-world manufacturing environment. Let's start with that perception of a Waisoki Pragwachishia, a high-entry barrier, especially for firms that might not have extensive prior digitalization experience or large IT departments.
Okay.
DBR77 solutions are uniquely designed with a human-centric spirit, focusing intensely on simplicity and intuitiveness. What this means practically is that users can actually access and effectively use most functionalities after just a few hours of focused training. This significantly reduces the initial learning curve and minimizes the need for extensive, costly external IT experts just to get started. They also provide comprehensive educational materials, detailed case studies, the online DBR77 Academy, informative webinars, all designed to help users quickly grasp the concepts and maximize their use of the platform from day one.
That makes a lot of sense. Simplifying the user experience and providing robust support can really democratize access to this kind of advanced technology, making it genuinely available to a wider range of businesses, not just the giant corporations. What about the inherent complexity in large organizations with their sprawling, often siloed existing IT ecosystems? Integrating into that must be tough.
Yeah, that's a big one. For firms with complex existing ERP, MES, and WMS ecosystems, DBR77 operates entirely in a browser environment. Now, this is key because it dramatically simplifies deployment. It doesn't require any modifications to their existing, often deeply embedded and sometimes fragile IT infrastructure.
Ah, okay.
Yeah.
No big install nightmare.
Hopefully not. A carefully designed and robust API enables seamless integration with these existing systems, allowing DBR77 to pull data from them and push optimized schedules back effortlessly. Crucially, DBR77's dedicated IT support team actively assists clients in these potentially complex integration projects, minimizing the time costs and significantly reducing the risk of downtime during implementation, which is often a major concern for any business.
So it's designed not to rip and replace critical existing systems, but rather to intelligently connect with and enhance them. That seems much more practical. And the issue of data quality dependence, you mentioned it earlier, that's a monumental one for AI and simulation, where garbage in usually means garbage out, right?
Absolutely. Recognizing that the effectiveness of AI and simulation is directly dependent on the quality of the data feeding them, DBR77 offers its own hardware, like those Tsujiki sensors we discussed, and a comprehensive system to collect high-quality real-time data directly from production lines if needed. But importantly, even if a client's live data streams are initially limited or perhaps inconsistent, DBR77 provides a Bazada Danich standard widget, a standard database for initial simulations.
How does that help?
Well, while the precision might be slightly lower without complete live data from your specific machines, this baseline often proves sufficient to identify major problems and significant areas for immediate improvement. It allows clients to derive tangible value and initial insights almost from day one, rather than having to wait months and months to perfect their data collection infrastructure before seeing any benefit.
That's incredibly clever, providing a functional starting point even for less mature data environments, so businesses can see value right away and build confidence. What about the notoriously long decision cycle that often plagues industrial clients when considering new technology? It can delay innovation for years sometimes.
Yeah, the Doogie cycle, DCC Clantal Prezi. The long decision cycle of industrial clients is a well-known challenge. To counter this, DBR77 strategically focuses on pilot projects. This approach allows clients to test the solution on a smaller scale, maybe targeting specific production lines or particularly problematic processes, and rapidly verify its tangible effects and ROI before committing to a full-scale, potentially expensive rollout across the entire facility.
Makes sense. Prove it first.
Exactly. Plus, their flexible subscription model also eliminates the need for high upfront capital expenditures, which significantly accelerates purchasing decisions and, in turn, offers a quicker path to return on investment. This combination of a low entry barrier and proven high ROI strongly encourages full-scale implementation after a successful pilot phase.
It's a very smart way to de-risk the initial investment for companies, making that leap to advanced technology feel less daunting financially and operationally. And the need for a strong integration partner network, Konishnoshish Budui Silni Siachi Partner Row Integrasinish. How does DBR77 facilitate that, given the specialized nature of many of these projects? Finding the right experts can be hard.
Right. Addressing this necessity, DBR77's marketplace is absolutely key. It serves as a dynamic ecosystem connecting production companies with, as I mentioned, over 800 technology providers and 600 integrators, forming arguably the largest platform of its kind in the industrial space focused on this. This provides clients with a true one-stop shop for specialists and solutions. If a simulated optimization suggests a specific automation solution is needed, or if implementing requires an expert integrator with specific skills, the marketplace drastically shortens the time needed to find, vet, and onboard qualified partners for digital transformation and automation projects. It accelerates the entire process significantly.
So it's not just selling software, but actively cultivating an entire ecosystem around it that ensures successful implementation and ongoing support. That's quite comprehensive. And what about the very legitimate concerns around muliwi problems that present warzenium danatrikmor's possible cloud data processing issues, especially with highly sensitive operational data from a manufacturing plant? Security is paramount.
Absolutely. For potential issues with processing sensitive data in the cloud, DBR77 operates with the highest security standards, adhering strictly to ISO 27771 certification. All client data is securely stored on AWS servers located in Frankfurt, Germany, which fully meets the rigorous RODO GDPR requirements for data protection within the European Union. Furthermore, it's strictly a B2B platform, and all users, clients, integrators, technology providers sign mutual non-disclosure agreements, NDAs, comprehensively protecting not just the raw production data, but also sensitive commercial information shared across the platform. Security and compliance are treated as absolute non-negotiables.
Security and compliance are indeed paramount, especially in complex industrial settings where data integrity and intellectual property privacy are critical. Finally, how does DBR77 directly address the often waisoki wamagania dodichech ROI dula cliento, the high ROI requirements from clients before they commit to such significant technological shifts? They need to see the payback.
Yeah, the high ROI requirements from clients are met through a multifaceted approach. The already mentioned low initial cost via the subscription model significantly contributes to enabling a rapid ROI, making the financial commitment much more manageable upfront. Additionally, the integrated marketplace helps clients not only find but strategically select the optimal solutions and technologies precisely tailored for their specific plant needs and budget. This strategic matching significantly shortens implementation time and dramatically increases the chances of quickly seeing tangible, positive effects on their operations, like reduced downtime or faster throughput, thereby accelerating the return on investment and building a strong, quantifiable business case for continued digitalization.
It really is a testament to truly understanding the market that DBR77 seems to have systematically built solutions for each of these common real-world pain points. It feels like they're paving an incredibly smoother, more accessible path to digital transformation for manufacturing. They've genuinely thought through the entire customer journey and proactively removed many of the traditional blockers that would typically deter businesses, especially smaller or mid-sized ones.
This holistic approach makes these advanced technologies far more accessible, practical, and ultimately more likely to be successful for industrial enterprises of virtually all sizes and levels of digital maturity. It lowers the barriers significantly.
Okay, so if you're listening, maybe you're a manufacturing professional, a plant manager, an operations director, or frankly, anyone who's ready to take precise control of your production planning and move beyond that frustrating, shifting sand feeling. What are the concrete, practical steps you can actually take to begin this journey? How do you move towards more precise, predictable planning in your own facility?
Yeah, it's important to remember this is a continuous journey of improvement, not like a single project with an end date. But there are definitely clear and actionable starting points. First, I'd say, conduct a thorough audit dostupnych Ganachei Systemo, an audit of your available data and existing systems. You absolutely need a clear understanding of your current data landscape. What data are you already collecting? Where is it stored? What formats is it in? What existing technological infrastructure is in place, like your ERP or MES systems? This baseline assessment is crucial for identifying gaps and, just as importantly, leveraging what you already have. Don't reinvent the wheel if you don't have to.
Right. Know your starting point. Before you even think about buying new technology, know what you're truly working with on the ground. Makes sense.
Exactly. Second, prioritize zbieranie Danish WJZ RZD-Systems and NEMIS I magazine real-time data collection for machines and the warehouse. This, as we've said, is the lifeblood of precise planning. This might involve implementing new IoT sensors on older machinery that doesn't currently provide data, integrating data streams from modern equipment that already has connectivity, or even setting up automated inventory tracking systems in your warehouse using barcodes or RFID. The goal is to gather live, granular operational data that reflects the true pulse of your factory, moving beyond outdated manual entries or delayed batch reports.
Get that real, immediate pulse of your factory floor, moment by moment, not just looking back at last week's numbers.
Precisely. Third, once you have some data flowing, proceed with Budoa Cifrawego Bluniaca Lobe Modulu Processo, building a digital twin, or at least a process model of your operations. You can start small here. You don't need to model the entire factory on day one. Maybe begin with a specific critical production line or a known bottleneck process. Create a virtual representation that allows you to visualize, analyze, and interact with your real-time data in a much more intuitive and dynamic way than traditional spreadsheets or static process diagrams ever could. This digital model becomes your living, breathing operational blueprint.
That's your virtual sandbox we talked about, where you can play around without breaking anything in the real world.
Which logically leads to step 4. The simulacta runis varianto harmonogramo, the simulation of various schedule variants. Once you have your digital model, use it rigorously to test different planning scenarios. Run those countless what-if analyses we discussed for new large orders, simulate the impact of potential machine breakdowns, model the effects of material delays. This allows you to identify the most robust and efficient plans, predict potential issues before they happen, and optimize resource allocation without risking any real-world disruptions or costly trial and error mistakes.
Then, once you've used the simulation to find what looks like the optimal plan, it's time to actually put it into action, right?
Yes. Fifth is Gudruni optimalnego planus lulivoshi sipki correcti. Implement the optimal plan. But crucially, ensure it has rapid correction capability built in or supported by your system. Don't aim for absolute perfection from day one. The real industrial world is just too dynamic and unpredictable for that. Implement the best plan identified through your simulations, but ensure your system and your processes allow for quick, agile adjustments based on real-world feedback and unexpected events that will inevitably occur. Agility and adaptability are absolutely key to continuous improvement in planning.
And finally, this isn't a set it and forget it kind of solution, is it? It sounds like a living system that requires continuous engagement and refinement.
Precisely. Step 6 is Stanie monitorowanie realizacji. Adaptacja harmonogramu, continuous monitoring of implementation and ongoing schedule adaptation. Use that continuous stream of real-time data to monitor the execution of your plan constantly. Are there discrepancies between the plan and reality? Are new bottlenecks emerging unexpectedly? Is a particular machine underperforming compared to its simulated capability? Use this ongoing data stream to refine and adjust your plans, maintaining that crucial agility. The industrial environment is constantly changing. Customer demands shift. Suppliers have issues. Machines need maintenance, so your planning needs to be dynamic, constantly improving and adapting based on live performance data and new information.
So this isn't a one-time fix. It's truly a continuous journey of improvement, leveraging technology to create an adaptive and incredibly resilient operation. Each step really builds on the last, creating this powerful, potentially self-optimizing cycle within the factory.
It's about fostering a pervasive culture of data-driven, proactive management throughout the entire organization from top to bottom. Not just a tool for the planners, but a way of thinking for everyone.
Let's bring it all back then to the ultimate payoff. Why does all this effort, all this technology, all this data analysis matter for the long run? Beyond the individual benefits we've discussed, like cost savings or efficiency, what's the overarching strategic impact of embracing precise planning for businesses operating in today's demanding industrial landscape?
Yeah, the ultimate payoff is profoundly multifaceted, and it directly touches core business outcomes and your overall competitive positioning. First, as we saw, zoptymalizowanie harmonogramy pozwala punktualnie dostoi na przyjęcie zmiany zlecie. Optimized schedules allow for punctual deliveries even with high-order variability. This means you can confidently commit to and consistently meet deadlines, even when faced with fluctuating customer demands or unexpected internal changes. This capability becomes a critical competitive differentiator in today's market, enabling you to capture more business and build an unparalleled reputation for reliability. Customers value that immensely.
That flexibility combined with consistent reliability sounds incredibly valuable. It also seems like it would fundamentally streamline inventory management, potentially freeing up significant capital.
It absolutely does. Precise planning leads to a significantly zmniejszenie potrzeby utrzymywania wysokości zapasu, biz pizza jeswa, reduced need to maintain high safety stock levels. By accurately predicting material needs based on real demand and ensuring timely delivery of components and raw materials just when they're needed, you can operate with much leaner inventories. This frees up substantial working capital that would otherwise be tied up sitting stagnant in stock on warehouse shelves. It also frees up valuable physical storage space and reduces carrying costs like insurance and handling, directly impacting your financial efficiency. It supports lean principles.
And it creates a powerful positive ripple effect, doesn't it? A smoother flow across the entire supply chain, from raw materials coming in to finished goods going out.
Exactly. You'll experience lepsu bezpospres logistika I magazinem, much better cooperation and synergy with your logistics and warehousing departments. When production schedules are precise and predictable, logistics teams can plan transportation routes more efficiently, optimize truck loading and unloading times, and warehouse operations can manage inbound and outbound flows far more seamlessly. This creates a much smoother, more coordinated flow across your entire internal and external supply chain, reducing delays, minimizing those expensive rush shipments, and lowering overall logistics costs. Everything just works better together.
And what's the ultimate strategic advantage that a business gains from all of this integrated effort? What's the big prize?
Ultimately, this leads to a powerful dual benefit. Zwiększenie ilości klientów i zdolności do realizowania większej liczby zamówień. Increased customer loyalty, and the enhanced ability to fulfill more orders simultaneously. By consistently meeting deadlines, offering greater flexibility to changing customer demands, and optimizing your internal operations to this degree, you build far stronger, more trusting customer relationships. They stick with you. At the same time, because you're using your resources more efficiently, your effective operational capacity significantly increases without necessarily expanding your physical footprint or investing heavily in new equipment.
So you can do more with less, essentially.
Pretty much. This isn't just about incremental efficiency gains anymore. It's about building a fundamentally robust, agile, and truly customer-centric industrial operation. one that can outmaneuver less agile competitors, capture greater market share, and remain resilient in an ever-changing, often disruptive world.
This truly demonstrates that precise production planning, powered by real-time data, sophisticated simulation, and integrated platforms like DBR77, is really no longer a luxury or some kind of futuristic concept. It's an absolute strategic imperative for industrial professionals looking to thrive, not just survive. It fundamentally empowers companies to move away from that reactive firefighting and constant uncertainty towards proactive, predictable excellence. It's about truly taking control of your future rather than just reacting to today's latest crisis.
It fundamentally changes the operational paradigm. It builds resilience and strategic advantage right into the very core of your business operations.
So it leaves us with a thought. In a world of constant change and increasing complexity, is a fixed, rigid plan really an asset anymore? Or is it actually becoming a liability? And how can technology help us build plans that are both precise and resilient, ready to adapt intelligently to whatever tomorrow brings, ensuring not just survival, but sustained growth and competitiveness?
That's a truly provocative thought, and it perfectly highlights the critical need for dynamic, adaptive strategies in our incredibly dynamic industrial environments today. Static plans just don't cut it anymore.
Indeed. We really encourage you, our listener, to consider your own current planning processes in light of this discussion. Think about how these advanced tools and concepts could potentially unlock entirely new levels of efficiency, predictability, and ultimately competitive advantage in your own operations. Thanks for joining us for this deep dive.